Good evening, everybody, and tonight we're going to be taking a look at solving variables on both sides. What do we do? What's the best strategy for dealing with that when we have a variable on both sides of our equal sign? And the other thing is we're going to start recognizing problems with either infinite solutions or no solutions. And they're actually pretty easy, but the first couple of times you run across them, you may think you've actually made a mistake with your math. So I'm going to point those out for you tonight, and then tomorrow we'll have plenty of time to practice them in class, and then you'll have some more IXL practice on it. So let's get started. As you can see here, I've already started a problem, and I've looked at it, and I've simplified by using the distributive property, and I've isolated my variable. I've combined like terms, and so now I'm left with 2w minus 1 equals 3w minus 3. And so my next step is to isolate. Well, which do I do first, since I not only have a w and a number on one side, but I have a w and a number on the other side? I want you to think about this. It's always easy to deal with positive numbers versus negative numbers. So which of these two values, 2w or 3w, is the smallest? Okay, so the 2w is the smallest. So we're going to always choose the smallest value for the variable, and we're going to eliminate it first. So we're going to use the additive inverse. So the additive inverse of 2w is negative 2w. What we do on one side, we do on the other side. So this is eliminated. I'm left with negative 1 equals w minus 3. You see how this is a positive number here? If I'd have subtracted negative 3w, then over on this side I would have also subtracted negative 3w, and I would have been left with a negative variable. And that's not to say that we can't solve that. We would end up just dividing by a negative to get rid of the negative, but it's just one more step and one more opportunity to make a mistake. So on here, from here, we just add 3 to both sides, and we have 2 equals w. Now it's not required, but if you'd like to change that to w equals 2, that's also quite acceptable. In other words, 2 equals w, w equals 2 is exactly the same thing. We didn't even need to divide here. W was just a coefficient of 1. Okay, let's take a look at another example where my numbers are negative. So I have 2. Hang on a second, I'm just going to pause this and I'm going to finish this out for you. 1 second. Sorry about that, just wanted to save a little time. So as you can see, I have simplified this. Alright, now we're just looking to isolate. So this is slightly different because we have a 2w here and we have a negative 3w over here. So which of those values is the smallest value? Would you rather have $2 or would you rather owe $3? Well, I don't know about you, but I'd rather have $2 than owe $3. So negative 3w is obviously the smallest value here. How do I get rid of the negative 3w? I use the additive inverse. I do on one side, I do on the other. What happens to the negative 3w and the positive 3w? It disappears, so the only thing that I'm left with on this side is 3. Over here I have 5. I have 2w plus 3w gives me 5w minus 2. Add 2 to both sides. 5w equals 5, and I think you can finish that from there. Isolate, and then we just divide out the 5 to finish. So you can see up here, I looked at, okay, the 2w, if I subtract 2w, now I have negative 5w. Again, could we work with it? Yes, but it would just make our lives a little bit more complicated. It's so much easier to choose the smallest value and get rid of it, eliminate it by using the additive inverse. Okay, well, like I said, we'll have plenty of practice with that tomorrow in class, but for now, that's something I want you to think about when you are dealing with a variable on both sides, is which one of those values is the smallest value. I'm going to eliminate that value and then continue to solve from there. Okay, the next thing we're going to take a look at is when we have either no solutions or infinite solutions. So here we have a simple problem, negative 6x and negative 6x. And so they're exactly the same value. So we're just going to add 6x to both sides. Add 6x to both sides. And I'm left with negative 7 equals 2. Well, is that a true statement? Does negative 7 equal 2? Well, of course it doesn't. Okay, so what we're really saying is there is absolutely no value of x in which this will make this statement, negative 7 minus 6x equals negative 6x plus 2, true. So our answer is no solutions. So if you end up with a statement that says that this value is equal to a different value, then your answer is absolutely no solutions. Now I want to caution you here. 3x equals x. Some of you may want to jump on this as no solutions, but let's continue the problem. Which of these is the smallest x? The one on the right. We're going to subtract x. We're going to subtract x. I now have 2x equals 0. Next step, simplify, isolate, divide. I divide by 2. I divide by 2. X equals, well, nothing. 0 divided by 2 is 0. Is there a solution for x? Absolutely. 0. If I plug 0 in here and 0 in here, 3 times 0 is 0. X is 0. Does 0 equal 0? So please be careful when you end up with something that looks like this before you decide to say there are no solutions. When you have this, work your way through until you recognize it, but when we have just a variable equals another variable, then the answer is actually that the variable has to equal 0. So I caution you that because I've seen that mistake a couple of times before. So, no solutions is when we have a constant supposedly equal to another constant when they're obviously not the same. Then our answer is no solutions. Well, let's take a look at the opposite of that. In this particular situation, we have w equals 7w minus 6w equals w. What values of w will make this statement true? Well, we can start to think about this. If w equals 1, then w equals 1. 1 equals 1. Well, what about when w equals 2? 2 equals 2. 5 equals 5. So we call this an identity because it has infinite solutions. No matter what value I pick for w here, when I plug it into the original equation, then my answer will be true. So when I have a constant, when I have a variable equal to a variable, then I know that I have infinite solutions. How about a different example? Here I have x minus 2 equals distributive property. 2 times a half is x. 2 times negative 1 is negative 2. I subtract x from both sides and I end up with negative 2 equals negative 2. Is that a true statement? Well, obviously yes, negative 2 does equal negative 2. Once again, it doesn't matter what numbers I choose for x, the answer will always be equal. If I do 3 minus 2 equals 3 minus 2, true statement. 5 minus 2 equals 5 minus 2. Again, I'm just substituting in numbers for x to verify that the statement still holds true. And we could do that with an infinite number of solutions for x. So when I have the variable equals the variable, or the constant equals the constant, then I say that I have an identity and that I have infinite solutions. Alright, well, we'll take a look at that, and when you take the post-video quiz, if you do have questions on that, let me know. If you don't trust that those are infinite solutions, Pick 3 random numbers. How do you do the check step on something like this? It's pretty hard, really. You're going to have to choose at least 2 numbers and plug them in, because it has to work for both of those numbers. If it doesn't work for both numbers, then you don't have infinite solutions. I hope this made sense to you. We will be talking about it more in class tomorrow, and I look forward to seeing you guys tomorrow. Good night.